G'day everybody, Nick Dingle here again for another quick interlude video just on the back of our error handling and debugging video. I originally wasn't going to demonstrate this, but then I second guessed myself. So here I am, demonstrating to you the try keyword. Now this is a sledgehammer approach to handling errors. It is essentially going, this chunk of code may cause an error sometimes, and I would like to handle that in any way I possibly can. So I'm going to do what's called a try and a catch so my program doesn't crash. So on that note, it is specifically for runtime errors. It is not for logic errors, and it's definitely not for syntax errors because you should be handling that before you run your program. But let's jump into it. Let's say I've got this program here. I'm collecting two numbers from the user. I'm converting them to integers, and I'm storing them in my variables number 1 and number 2. I am then dividing those two, and then I'm displaying the result of the division on the screen. So let's give that a play. Let's type in a first number is 4, second number is 2, and division is 2. Excellent, so we know it works. However, what if the user decides to be an absolute poo-poo and type in 9 and 0? We get this lovely runtime error that says division by 0. So this might occur. The user can always be an idiot. In fact, the user could just go, first number is dog. All right. So there's lots of things that could potentially occur here. Some are easier to handle than others. Now I can handle both of these using if statements. The first one with the division by 0, I can just double check that number 2 is not equal to 0. That's a simple one. The second way is converting to an integer. I could just do that after and use what's called the isDigit function to check, did the user actually type in a digit? And if they did, convert it to an integer, do the division. I'm not going to show you those things. Go and Google them. It's pretty simple. But just as an example video, I'm going to focus on the division by 0 error because it is a pretty common occurrence in a lot of programs. So let's have a look at this. The user's going to type in crap, and you're going to have to deal with that crap because garbage in, garbage out. So how do we handle this with our sledgehammer? Well, you start off with what's called a try keyword, and you set the line of code that is going to cause the problem as the block of code that you want to try. So this is the line that might cause the runtime error. So it's the only one I'm going to put under the try line. Now it's having a whinge because whenever you write the word try, you have to have an except afterwards. Except is short for exception. And basically it's saying, if this code does not work, what do you want to do? All right. Well, in this case, I'm simply going to print something went wrong. Okay, I'll get back to the really crappy generic error messages in a second. Let's press play. Type in our normal number. So 1 and 2 gives us a half. So the code still works as normal. It still runs this. It jumps over the except part because nothing went wrong. And it still continued to run my program. And again, 9 and 0. Something went wrong. So it actually did fire off the except section now. It tried to do this bit. It failed, so it went into here. But then I got another runtime error because it tried to print my answer, but answer doesn't exist because this line never actually executed properly. So realistically, this line of code needs to pop up here. So do it again. And there we go. We're not getting that crash anymore because it's now in the try and accept. And if I am an idiot, it simply says something went wrong. And if I do something normal, it simply does the division and continues on with its merry little life, ignoring the exception part. Now, this, thanks Microsoft for these lovely something went wrong messages. And if you don't know what I'm talking about, Google something went wrong Microsoft. It's terrible. So it's always good to inform your user what the hell went wrong, even if it's a really simplistic version of that error. Like, you're an idiot. No, don't ever insult your user. That's bad. How do we actually know what happened? Well, what we can do is we can actually ask Python, well, what was the error message? So after the word accept, you type exception with a capital E as, and then you simply write a variable name. And for me, I'm just going to put E. For now, just E. So E is now going to be my variable that contains the error message of what occurred. Something went wrong. Let's change this to an F formatted string. So something went wrong and then the error message. Okay, play, first number 9 and then 0. something went wrong, division by 0. Perfect. Okay. So the thing that I want to quickly show you before I finish this video is that you can attach what's called an else onto try and accepts. All right. And what I'm going to do is move this line of code down to here. And the way else works is basically try this line of code. If something fails, run this line. If nothing went wrong, then do this. It's sort of like if everything went right, what do we want to do? So this is everything went wrong. This is everything went right. All right. And you don't have to do it like this. I'm just demonstrating. Okay. Because I needed to find somewhere to put it in. So the error still works. You'll notice it doesn't say division is anymore. But if I do the normal numbers, it simply says division is and then blah. All right, so there is our sledgehammer try keyword to fix up those really niggling runtime errors that might occur. Great chances of using this are things like you're trying to download a file and it errors out or the file doesn't exist, or you're trying to read a file and there's not as much data as you need, or it's corrupted or something like that. Those are great examples for when to use a try. Not examples like this, okay? But for now, I'll see you in the next video, everybody. Thanks for watching.